Hello everyone, we are from Group 1. We'll explain about our material by the title Group 12 Metals. As we know, in Group 12 metal consists of zinc, cadmium, and mercury. The first metal is zinc. It is found in Group 2b of the periodic table and have an important role in human life. Next is about properties of zinc. First is physical properties. The density of zinc is 7.13 grams per centimeter cubic. The color is bluish white. The melting point is 420. The elasticity and malleability increase when heated. The boiling point is 906, and at the temperature above 200 loses its elasticity, and the zinc is a good conductor. Next is chemical properties. Zinc is located in Group 2b of the periodic table. It has atomic weight 65.39 and the atomic number is 30. The oxidation state of zinc is +2. Next, about extraction of zinc. Metallic zinc is produced by roasting the sulfate ores and then either releasing the oxidized product in sulfuric acid. For the specific information of the mining, recovery, and refining of zinc, see the process.
Zinc concentrates are zinc ores that have been enriched after removal from the mine. They are delivered from all over the world in a granular bulk form. Enclosed conveyor belts transport the concentrates for temporary storage. Sulfuric acid is also shipped from the harbor. It is the main byproduct of the production of zinc. Zinc concentrates from various mines are temporarily stored. The crane picks up various types of concentrates, mixes them, and blends them in order to obtain the right mix, which makes for the specific needs of certain zinc refiners, ensuring the highest quality of refined zinc. The mixed concentrates are transported on conveyor belts to the roasters. In the roasting plant, the mix of zinc concentrates is introduced into fluidized bed furnaces. With the addition of air, the sulfur contained in the zinc concentrates is released and oxidized at about 1000 degrees Celsius to produce sulfur dioxide gas. This gas is then purified in several phases and transformed into sulfuric acid. Sulfuric acid is a key byproduct of the zinc production process, and it is an important base material for the chemical and pharmaceutical industries. The roasted zinc material is now mostly soluble in acid and is deposited towards the bottom of the roaster. Once cooled and ground, it is then pumped into the reservoir of the leaching plant. The roasted material from the mine is purified along with recycled material called a Welz oxide. The Welz oxide is an important raw material for making zinc. It is in the form of a powder produced from the recycling of zinc-coated steel. Both the roasted ore and the Welz oxide are purified in the leaching plant by dissolving in sulfuric acid. Any accompanying impurities are precipitated. This leach solution, free of solid matter, is then heated and purified in 3 phases prior to proceeding to the production of metallic zinc. Metallic zinc production is based on electrolysis. Lead and aluminum sheets are suspended in baths, which are filled with the zinc-containing leach solution or electrolyte. The sheets are connected in an electric circuit, where the lead sheet becomes the anode and the aluminum sheet becomes the cathode. The voltage drop across the anodes causes the zinc to deposit onto the aluminum sheets. The pure electrodeposited zinc is then peeled off the aluminum plates, washed, and transported to the melting furnace in the casting plant. The aluminum sheets will be put back in the electrolytic baths and reused to deposit more zinc from fresh zinc-containing electrolyte. The electrodeposited zinc from the electrolysis step is melted at over 420 degrees Celsius in induction furnaces and cast into slabs or jumbos weighing from 1 to 6 tons or into special shapes, depending on its use and the needs of the customer. In some cases, additions of small amounts of aluminum or other metals are added to meet customer requirements. Strict quality controls are followed during the casting process, including the regulation of returning scrap from the casting process to the melting furnace.
Now we learn about reaction of zinc. First, reaction with air. Zinc metal burns in air to form the white zinc 2 oxide, like this reaction. Next, reaction of zinc with the halogen. For example, reaction of zinc metal with bromine and iodine to produce white sediment. Third is reaction of zinc with acid, for example, sulfuric acid. Zinc metal dissolves slowly in dilute sulfuric acid to form solution containing the adequate Zn2 ions together with hydrogen gas. Next, reaction of zinc with hydroxide ion. Element zinc react with strong base, forming hydrogen, like this reaction. Next, reaction of zinc with aqueous ammonia. Zinc 2 ions react with aqueous ammonia to precipitate white gelatinous Zn hydroxide, like this reaction. Next, chemical bonding of zinc. First, ionic bonding. For example, zinc chloride. The ionic bond is formed by the electrostatic attraction between Cl- and Zn2+. Next is metallic bond. Metal bonds are chemical bonds that are formed as a result of sharing valence electrons between metal atoms. Metal bonds are the main force that hold metal atoms together. Metal bonds are a result of the positive charge attraction of the metal and the negative charge of free moving electron. As we know that zinc is a metal, then why does zinc form covalent bonds? Let's look at the following video.
In this video, we'll look at whether zinc chloride, that's ZnCl2, is ionic or covalent. Zinc chloride's a little bit of a tricky one. So let's first take a look at whether zinc and chlorine are metals and nonmetals. So we look for zinc, that's right here. That is a metal. And then chlorine over here, we have nonmetals. So we have metal and nonmetals. That normally means that this would be an ionic compound. And for many situations, this would be an acceptable answer. We could also look at data on the electronegativity difference between the zinc and the chlorine atoms. So here's a periodic table broken down. It's got the electronegativity differences written up here. When we look at zinc, we have 1.65. That's its electronegativity value. Chlorine over here, we have 3.16. So if we look at the difference between these two numbers, we get 1.51. In general, when we talk about ionic compounds, one of the definitions is the electronegativity difference between the elements is greater than 2. Some textbooks say greater than 1.7. So here we have 1.5. So we're really not an ionic compound, but we're close. So perhaps you could call this weakly ionic. When we look at data from the laboratory, one of the things we'll see is that if we have solid zinc chloride, it melts pretty easily compared to other compounds like sodium chloride. That kind of supports what we're saying here, is that it has a much more covalent character to it because it melts quite easily. So ionic compounds, covalent compounds, kind of a continuum between those. And zinc chloride is much more towards the weakly ionic compound.
The abundance of zinc in the Earth's crust is estimated to be around 0.02%. That places the element about number 24 on the list of elements in terms of their abundance. Zinc is found in nature combined with other elements as ores. The main ores or zinc are sphalerite, smithsonite, hemimorphite, and franklinite. Next, application of zinc. There are many applications of zinc in human life. First, galvanizing against corrosion. Zinc is commonly used to coat iron or steel to protect this metal against corrosion. Second, zinc is used in alloys such as brass, nickel, silver, etc. Third, zinc chloride is used as deodorant and as a wood preservative. Next, in human body, zinc needed as much as 15 mg per day for various functions to our body. Actually, there are many functions of zinc, but in this video, I just say several functions. Okay, I think that's all explanation about zinc. Let's continue to other metal in group.
The next metal is cadmium. Cadmium is the transition metals. Cadmium is in its elemental form a soft, silver-white metal. It's not usually present in environment as a pure metal, but most often as complex oxides, sulfides, and carbonates in zinc, lead, and copper ores. The atomic number of cadmium is 48. The atomic weight is 112.4. The symbol is cadmium is Cd. The electron configuration is Tr 4d10 5s2. The crystal structure is hexagonal. Cadmium is solid at 20 degrees Celsius or 68 degrees Fahrenheit, and the cadmium is the weakly basic elements. The other properties of cadmium, the atomic radius is 155. The melting point is 321.07. The boiling point of cadmium is 767.3 degrees Celsius. The density at 20 degrees Celsius is 8.65. Heat of fusion is 6.21. Heat of vaporization is 99.6. The electronegativity is 1.69. The first ionization energy is 867.8. The second ionization energy is 1631.4. Reaction of cadmium. Cadmium metals burns in air to form cadmium-2 oxide. This material is colored variously depending upon how it was made. The reaction is cadmium react to oxide and form 2 cadmium oxide. The cadmium metal doesn't react with water. Reaction of cadmium with base. Cadmium metal doesn't dissolve in aqueous alkalis such as potassium hydroxide. Reaction of cadmium with the halogens. Cadmium difluoride, cadmium 2-difluoride, cadmium dibromide, cadmium 2-dibromide, and cadmium diodide, cadmium 2-diodide are formed in the reaction of cadmium metal and fluorine, bromine, or iodine. Reaction of cadmium with acid. Cadmium metal dissolves slowly in dilute sulfuric acid to form solution containing the aqueous cadmium-2 ion together with hydrogen gas. The reaction of cadmium with acidic acid such as nitric acid are complex and depend upon precise conditions. the use of cadmium. As a result of its low coefficient of friction and its high fatigue resistance, cadmium is used in alloys for bearings. Cadmium is used in low melting alloys and is a component of many kinds of solder. It also is used in electroplating. Compounds containing cadmium are used in black and white television phosphors and in the blue and green phosphors for color television picture tubes. Cadmium sulfide is used as a yellow pigment, and cadmium selenide is used as a red pigment, often called cadmium red. Cadmium and tellurium can be compounded into CDTA, thin film photovoltaic modules whose physical characteristics are ideal for solar cell production. They are relatively low cost and have an almost perfect band depth for solar energy harvesting. Abundance of cadmium. Abundance Earth's crust 150 parts per billion by weight, 30 parts per billion by moles. Abundant solar system 6 parts per billion by weight, 70 parts per trillion by moles. The source cadmium most often occurs in small quantities associated with zinc ores such as sphalerite. Greenockite is the only cadmium mineral of any consequence. Almost all cadmium is obtained as a byproduct of zinc, copper, and lead ore refining operations.
chemical bonding of cadmium. The lattice parameter of cadmium are for A 2.98 Armstrong and C equal to 5.62 Armstrong, with C for A is 1.88. The shortest interatomic distances within the chain are 3.69 and 2.99 Armstrong. The coordination number is K equal to 12. Cadmium has 8 stable and 12 radioactive isotopes. So the fact that there are different interatomic distances determine the crystal structure, psychochemical properties, polymorphic transformation, and phase transition of cadmium, and leads us to conclude that the hexagonal close-packed structure of this element is due to the overlap of the outer spherical shells stabilized by the orbitals. So these are the unit cell projected into XY plane viewed along C6 axis. This is the hexagonal structure of cadmium.
Third, about mercury. In Indonesia we call it raksa dengan lambang Hg, nomor atomnya 80 dan juga atom relatifnya atau AR-nya 200,59. The introduction of mercury. Mercury is one of the most toxic elements and a threat to wildlife because it accumulates and magnifies to unsafe levels in aquatic food chain. Jadi, merkuri merupakan zat yang sangat berbahaya. This slide contains about properties of mercury. The base of mercury is liquid. Next, there is a melting point, there is a boiling point, there is a density atau massa jenis 13,534 gram per centimeter pangkat 3, the triple point, the critical point, the heat of fusion, heat of vaporization, and molar heat capacity. Here we are in the chemical properties of mercury. First, mercury has low solubility. Second, stable chemical properties, especially in the sediment environment. Third, has properties that bind into proteins so that bioconcentration occurs easily in the body of water organism through the food chain. 4. Evaporates and easily emits or releases toxic mercury vapor even soaked at room temperature. 5. Mercury metal is the only metal element in the form of liquid at room temperature or 25 degrees Celsius. 6. In the solid phase is gray in color. In the liquid phase is silver white. Jadi perbedaannya ketika dalam wujudnya yang padat, dia berwarna abu-abu. Tapi ketika dalam wujudnya yang cair, dia berwarna perak ke putih. 7. Mercury vapor in atmosphere can last for 3 months to 3 years. The water-soluble form lasts only a few weeks. Bonding of mercury. First, inorganic mercury. Inorganic mercury is a form of mercury in an oxidized state to form ions according to its oxidation state. Mercury in the ionic form can form mercury to positive or mercury positive ions depending on the level of oxidation. In the ionic form, mercury can bind with other elements such as chlorine to form mercury chlorine for oxidation state number 1 or mercury to chlorine 2 for oxidation state 2.
And now, reaction of mercury. First, I'm going to explain you about reaction of mercury with air. Mercury metal reacts in air at about 300 degrees of Celsius to form mercury oxide. So this is the reaction to mercury in solid phase. React with oxygen in gas phase, produce 2 mercury oxide in solid phase. And then with water. Mercury doesn't react with water under normal conditions.
And then reaction of mercury with halogens. Mercury metal reacts with halogens to form the halides mercury. So like this, mercury in liquid phase react with fluorine, produce mercury to fluoride in solid phase. And then mercury reacts with chlorine, produce mercury to chlorine. Mercury reacts with bromine, Br2, in liquid phase, produce HTBr2, mercury to bromide. And then mercury reacts with iodine in solid phase, produce HgI2, mercury to iodide in solid phase. Reaction of mercury with acid. Mercury doesn't react with non-oxidizing acid, but does react with concentrated nitric acid, HNO3, or concentrated sulfuric acid, H2SO4, to form mercury 2 compounds together with nitrogen or sulfur oxide. Mercury dissolves in slowly in dilute nitric acid to form mercury 1 nitrate, mercurous nitrate, HD2NO3 2 times. Reaction of mercury with the bases. Mercury doesn't react with alkalis under normal conditions. Now we move into extraction of mercury. Most of the world's mercury is obtained from its main ore, cinnabar or vermilion, with the chemical structure mercury sulfide, HGS. Cinnabar is usually found in a massive or granular form, but can also occur as small crystals. This ore is bright red in color, and small droplets of mercury metal can sometimes be found within the ore itself. The main areas for cinnabar mining are in Italy and Spain, which provide 50% of the world's mercury. Cinnabar in its crystal form. Mercury can be obtained from cinnabar by heating the cinnabar ore in a current of air and condensing the mercury vapor formed. Due to its relatively low boiling point, mercury can easily be purified by vacuum distillation. The reaction of mercury sulfide with oxygen is shown below. HGS plus O2 becomes Hd plus SO2. Other processes for the removal of mercury from cinnabar are also known, and the reactions are shown below. HGS plus Fa reduces Hg plus FAS. 4HGS plus 4CaO becomes 4Hg plus 3CaS plus CaSO4.
And the last is abundance of mercury atau kelimpahan merkuri. The abundance of mercury on Earth ranks 67 among other elements in Earth's crust. Jadi di sini kelimpahan merkuri di dunia ini pada ranking ke-67. In nature, mercury is found in the form of the element mercury, monovalent mercury, and bivalent mercury. Jadi di sini merkuri dalam alam dapat kita temukan dalam bentuk HgO, Hg1 positif atau Hg positif, dan Hg2 positif.